the HAWE Tech Podcast.
Hello and welcome to today's episode of the HAWE Tech Podcast. My name is Ralph and I'm Senior Specialist for Sales Enablement at HAWE. My guest today is Axel. Welcome, Axel. Nice to see you again.
Good to see you.
And you brought us a very interesting and practical question today. Do you know how an efficient hydraulic system for a machining center looks like? So I'm really curious to hear what you can tell us about that.
Yeah, I'm happy to do that. So efficiency is relevant for everybody of us. Efficiency in our case means mainly energy efficiency, and energy efficiency is important because on the one hand, it means reducing the CO2 footprint, which is important to save our climate, we know that. But for some people, or for the economy, even more important is that energy efficiency also means saving energy costs. Yeah, and that makes production saving cost less. So that's important.
Sounds good. Let's start with some basics. What is actually meant by a machining center, and why are hydraulics important in that?
Okay, a machining center is a machine tool, which combines different manufacturing processes. The main one is milling, but it can be also drilling and also thread cutting, things like that, whenever the tool is rotating. So the drives for this machining are typically electromechanical, but there are several secondary functions, so-called secondary functions, which are actuated hydraulics. And this is where the hydraulics comes into the play.
Okay. What are some of these secondary functions you just mentioned?
The main one sounds very simple. It is quite simple. It's the clamping and unclamping of the tool. So we heard about that machining center can make different machining processes, and in between we have to exchange the tool. And therefore the tool needs to be unclamped and the other tool needs to be clamped. And this function requires a high force, and it has to be fast. And that is what we can do very well with hydraulics. And this is the main hydraulic function in the machining center, clamping and unclamping the tool.
Okay. What other secondary functions are there that are involved in hydraulics?
Oh, there are several ones. So, for example, clamping of axes, the pallet changing. So several workpieces are adjusted on pallets, and exchanging the pallets can be a hydraulic function, or often is a hydraulic function. And even the clamping of the workpieces itself can be hydraulics. Other functions are possible. This is depending on the machine. But the good thing is, with one hydraulic power unit, I can activate several hydraulic functions. So even if there's one more, I don't have to add another drive, as I would have to do with an electromechanic drive. So.
Okay. Yeah, I'm aware of that. That's where the valve banks come in. But now, can you tell me something about the topic today, which is efficient hydraulics for machining centers? Let's get into depth there.
Okay, yeah, we should do so. Let's come back to the functions. So when we look into the functions, into the hydraulic functions in the machining center, we will see that these clamping, unclamping of the tool, the clamping of the axis, all these functions are leakage-free. That means once we activated the function, then we don't need hydraulic power anymore to compensate some kind of losses. And that is an important thing which allows us to make our system very efficient.
Leakage-free is something I remember from our seated valves.
Exactly. These are those 2 points which come together, leakage-free functions and leakage-free valves. And this is how our efficient systems are working. So what we do is, once we activate the function, we do not need to supply hydraulic power into the system anymore.
Okay.
And we can switch off the power unit.
So, as you just said, so we always restart the unit when a tool needs to be changed, for example, correct?
No, not exactly. Because in that case, we would have to restart the power unit every time when a function is activated. And that would put a heavy load on the motor, on the pump, on the coupling. And therefore, we use an intermediate storage tank for the hydraulic energy.
Okay, I remember that from a previous podcast where we talked about the accumulators. Is that correct?
That's exactly what we are talking about, hydraulic accumulators, and we are storing volume into the hydraulic accumulator.
Okay, so the volume that we hold in reserve depends on the accumulator size, if I remember correctly, and the difference between switch off and switch on pressure. So to charge the accumulator, we switch the power unit off, and the function can then still be carried out quickly if required because we have that pressure already in the accumulator.
Perfect.
Okay.
Pretty good memory. So, but that is how the combination of the system is. So, leakage-free functions, leakage-free seated valves, an hydraulic accumulator, which provides the required high flow for each function, and the hydraulic unit will only restart to refill the accumulator. And therefore, we have the power unit only running a few times only as long as it is needed. And this is the most efficient way to run a power unit in such a system.
Okay, you just mentioned efficiency. So how much more efficient are we then compared to a power unit that runs permanently? Must be a big number probably.
It is, and it is. It was proved by some studies. One was carried out by the University of Darmstadt a few years ago, and it showed that we can save about 80% of energy compared to a power unit which is permanently running. So 80% already sounds much, but when we really calculate that into money and consider a 2.2 kilowatt power unit running in 2 shifts, running for roughly 250 days a year, which is a common value, then we end with a number of 700 euro that can be saved compared to a continuously running unit.
Okay.
And this is only the power unit. So a constantly running unit may need a cooling system, which also consumes energy. So it's really a good amount of money that can be saved with such an energy efficient on-off system.
Well, that sounds pretty efficient to me.
It is.
And it should pay off pretty quickly too.
It does.
So let me summarize for our audience real quick all those interesting facts you just mentioned. So an efficient hydraulic system for a machining center takes over all hydraulic functions. These are generally leak-free, as you mentioned. The power unit is equipped with seated valves, so there are no losses even in the valve bank. The volume flow for the functions is provided from the accumulator. And the power unit fills the accumulator and can then be switched off. And this means that we have energy savings of up to 80%. And when we compare to a conventional power unit.
Yep.
Did I miss anything?
No, that was perfect. And what I didn't mention is, in addition to the energy, we also save space because our power units are more compact. We save maintenance because our power units are running less. But this is even worth an additional episode of our podcast. Let's do that later on.
Well, that sounds great. Then I'll thank you for being my guest today. It was very interesting as
Pleasure
usual.
for me.
And thank you to our audience for partaking again of the HAWE Tech Podcast. We look forward to seeing you in 2 weeks for our next episode. Thank you and goodbye.
Thank you.